This video introduces a software package that simplifies setting up a multi-OS environment and provides sample programs demonstrating interprocessor communication between CPU cores. Here are the abbreviations and terms used in this video. In the first part, you will be introduced to an overview about multi-OS. Before exploring the multi-OS package, we recommend watching our previous video on OpenAMP. The reference link is available in the video description below. It explains key concepts and benefits to help you understand the multi-OS architecture more easily. The RZ Multi-OS package provides software for developing multi-OS solutions. It combines the RZ Flexible Software Package (FSP) and the OpenAMP library for interprocessor communication. You can download multi-OS packages for the RZV, RZG, RZT, and RZN series from the Renesas website. In this video, we will use the RZT multi-OS package as an example for demonstration. Once the multi-OS package has been downloaded and extracted, these files will be available. The RZT2H multi-OS package provides a release note, quick start guide, and application note to support developers in efficient implementation and effective utilization. The RZT2H multi-OS package provides multi-core applications and sample programs, including bare metal, FreeRTOS, Linux on the CA55 core, and bare metal, FreeRTOS on the CR52 core. It helps developers explore and implement multi-OS solutions efficiently. Next, let's extract the meta-rz multi-os.tar.gz file. After extracting the meta-rz multi-OS package, you will get the recipes used for building the multi-OS on Linux. After that, let's extract the RZT2H multiple core application.zip file and check its contents. After extraction, folders will appear in the directory. Inside the IAR folder, you will find multiple compressed files for different core combinations. Each file contains sample programs for bare metal, FreeRTOS, and Linux configurations. Next, open the GCC folder to view the sample programs for GCC build environment. Using the RZT2H multi-OS package, you can mix operating systems across cores as shown. CA55 supports Linux, FreeRTOS, or bare metal, while CR52 supports FreeRTOS or bare metal. This flexibility allows a balance between advanced OS features and real-time responsiveness. In this video, we will demonstrate the Linux FSP combination. In addition, the multi-OS package supports various boot methods for secondary cores, such as the debugger, BL2, uboot, and remote proc methods. You can choose the one that best fits your development or deployment scenario. In this demonstration, the CR52 CPU0 runs FreeRTOS included in the package, while the CA55 CPU0 operates under Linux. This demo boots using the debugger boot method. In the second part, the segment starts with an overview of the Linux FSP sample program. This diagram illustrates the communication architecture between Linux and FreeRTOS via OpenAMP in a multi-OS environment. The left side represents the application core, CA55, which runs Linux. It leverages remote proc to manage the remote core and RP message for interprocessor communication. The right side shows the real-time core, CR52, running FreeRTOS. Through OpenAMP, it supports structured, message-driven communication with the Linux core. Communication between the cores is handled by RP Message and OpenAMP. RP Message provides the message channel, and OpenAMP bridges Linux and FreeRTOS for seamless, standardized interaction. Next, the reference program flow for OpenAMP communication between the application core and real-time core will be explained. It represents the baseline model of request, processing, and response in multi-core, multi-OS systems. In the third part, you will walk through the overall process and flow of the demo. Firstly, build Linux OS with additional MetaRZ multi-OS layer, which is a Yocto meta layer. Remember to choose the right device family being used. After downloading Linux BSP from Renes's website, extract it in Linux PC. Next, download multi-OS package, extract the MetaRZ multi-OS layer into Linux BSP directory, same level with other meta directories of Linux BSP. Use command shown in multi-OS application note to add MetaRZ multi-OS layer to Linux BSP before moving to next step. Next, build the Yocto project to get OS image and bootloader files. This will take a long time to fetch and build Linux BSP with MetaRZ multi-OS layer. When building is done, get the Linux OS image and flash it into SD card. Also for bootloader files, flash 2 files which described in multi-OS application note into RZT2HEVB evaluation board. Check board setting before flashing to ensure there is no error will occur. When hardware is ready, switch board to boot from SD card, then insert the flashed SD card to slot. Connect board to PC using serial port, open TerraTerm and configure with settings specified in multi-OS application note. Extract the demo project provided in the multi-OS package, then import it into eSquare Studio and build the project. After a successful build, flash the program to the board using the JLink debugger. For run or debug setup, refer to the multi-OS application note. Here is an overview of how the demonstration works. After logging in with root account, a command is called on Linux console to trigger the echo test program. At this time, the OpenAMP works as bridge to communicate between master processors and remote processor. Remote processor will receive messages and reply back to master processors. This message will pass through OpenAMP library again to send to master processors. When echo test program is done, Linux console will show result and FSP console show some information about running program. In the final part, you will be introduced to the multi-OS operation using Linux on the CA55 core and FreeRTOS on the CR52 core. Before running the example, let's build the Linux OS with multi-OS package and set up hardware following the previous video guideline. Since Guide to Build Linux with OpenAMP and Guide to Build FSP-RTOS with OpenAMP are already explained in the RZT2H RZN2H Quick Start Guide Linux and FSP video, please refer the previous video for information. Then import example project from multi-OS package to eSquare Studio workspace. When finished Linux building and project in eSquare Studio successfully, process to next step. When Linux BSP building is done, follow guide to run it on board. Launch TerraTerm and configure it using the previously specified settings. Power on to boot the Linux kernel flashed on the board. Once project in eSquare Studio is built successfully, you can start it. Use the same configuration for communication with TerraTerm to open the remaining serial port. This TerraTerm window will show on console log in eSquare Studio. Click the debug icon and open Debug Configuration to set the required settings. On the Debug Configuration screen, set the configuration following application note. After the debugging process starts, a screen will appear. Click the switch button to proceed. Press F8 or click the icon to continue program execution. Program may require clicking the icon twice when executing. After execution, on the FSP console will show the init state indicating that FSP program has set up the endpoint and ready to continue. Come back to Linux console, enter command rpmsg sample client 0 into console to start the echo test program. Program may take minutes to execute, and on Linux console we will see the result and check that if there is any error while communicating with FSP. Also on the FSP console, some IPI status and FSP endpoint status is shown. To stop the Linux kernel, run the shutdown command in the term screen. The shutdown sequence will start, and a message saying reboot, power down will appear on the term screen. Then, power off the board,